Well, good afternoon, everyone. My name is Duncan Brigginshaw. I'm a co-founder and technical director for Odin Technology. Obviously conscious that the track is running a little late today, and I'm the last thing between you and lunch, so hopefully I'll keep it short and sweet. But as a functional practitioner in the testing space, I'm used to being pressed up against a deadline, so I think we can manage that. I'm here to talk about a implementation we did at Clearstream for test automation and building a collaborative approach to automation, specifically with this case study in mind. So in today's talk, we're going to talk a little bit about Clearstream's objectives, their background and business drivers in the functional automation space, how they went about defining this approach to test automation, and then looking at a specific case study that they used to pilot the automation methodology that they came to realize. And then we'll look at some of the lessons and conclusions out of this approach. Just to introduce some of the participants in all of this, I myself work for Odin Technology. We're a QA software vendor. We're providers of a low-code enterprise automation platform focused on UI automation. And in fact, that's going to be the purpose of the talk today. We've been hearing a lot about APIs, FPGA, low-level latency, and testing at the API level. Today's case study is going to focus on UI automation, and often one of the more challenging aspects of automation. If you consider that APIs are built to be machine readable, then they obviously lend themselves very well to automation. So the challenges are slightly less, whereas UIs have been traditionally, as we heard from previous track talks, automated at rates of around about 15–20%. We want to raise that automation level up to a much more significant amount. Obviously with UIs, we're all moving towards presenting our clients and our customers with more and more UIs. We've heard from Niraj about the move towards mobile platforms for trading. We've heard from Sergey earlier on in his keynote on applying widgets for manual intervention in trading processes. So we are presenting our customers with more and more UIs. And by doing so, if those UIs don't work, then we present a number of risks, both on the financial basis and also our brand and our reputation. And we expose ourselves to reputational damage. So if defects are getting into production, we're aware of the reasons that we need better functional automation to improve the coverage of our UI testing. As Chris said in his keynote, Chris Corrado earlier, if it doesn't work to customers' expectations, then we're going to go out of business. Okay, so it's quite important, functional UI testing. We're here alongside Clearstream today, and we've got a couple of representatives from Clearstream in the audience who hopefully can take any questions you have maybe later on how their experiences played out. For those of you who aren't familiar with Clearstream, international CSD provider based in Luxembourg, post-trade infrastructure and security service, and a CSD based out of Frankfurt as well. Their parent company, Deutsche Börse, I think you may have come across that name, particularly with recent announcements. They're a diversified exchange organization. Obviously, we all know what they do. So I won't spend too long on describing the people we're talking about today. Some background. Functional automation was seen as key within Clearstream to achieving their business goals, lowering their risk in go-to-market. Their history is probably familiar to a lot of you today in the GUI automation space. There was isolated pockets of automation with limited success in various different business units, operating on their own principles and methodologies that didn't have any cohesion across the business, perhaps, primarily based on HP products. And those efforts were technical in nature, requiring quite a significant technical resource and input to achieve the automation rates they were. They went down the route of centralizing and building an automation framework, developing that in-house. Obviously, building an in-house automation framework means that you're developing your own software to do something. And obviously, that has its own expense and potentially isn't the focus of the business as a whole. And GUI automation rates weren't in line with business goals. So the move towards a collaborative test automation approach. Effectively, a high-level vision was defined, and one of the key components of that vision was the involvement of the business in automation. It's one of the dilemmas that test automation, certainly at the UI level, faces today, is the dilemma of the technicality of the tools involved and the requirement to capture the business and domain level knowledge into those tools. How do we get one to the other? So one of their key goals was to involve functional analysts and testers without technical skills in the automation process. The requirements were scriptless, business-focused architecture across the whole piece, tool independent, so they could operate against multiple interfaces under test using existing infrastructure investment in tooling, as well as open source tools and other future tools that they may consider, as well as being compatible with existing investment in HP tool sets. So the process they went through: initial RFP, a matrix scoring on the requirements and how the RFP proposers scored against that, shortlisted vendor, typical kind of process, define a methodology, and then get into project, which is the subject of the case study today. Another challenge that Clearstream faced was the disparate nature of the teams, organizational structure, and the geographies involved. Okay, so we all face these challenges in large organizations where we have business units located in, say, Central Europe. We have technical test teams, functional testers in nearshore environments, as well as our offshore partners and providers. And we've got to unify all those people to achieve our automation goals, and obviously invest in the support of tool vendors as well in this. So to talk about some of the skill sets involved across those, we had functional test analysts, so people with business experience who represented the business units, understood the requirements of the systems that were being tested, as well as our test designers, our functional testers, and a pool of technical resource to support this whole process. So those with the technical level skills, as well as to build the infrastructure of tooling as well that's required. And some other lowlifes down here, the project managers and developers and people of that nature as well, who make it to the bottom of the slide, but obviously equally important. I won't go into detail on this, you'll be pleased to hear, but one of the key things was to define responsibilities, a clear matrix of who was responsible to what inputs into that automation process, whether it was development, whether it was automation leaders, or the people from the business units themselves, the functional analysts. Each had a clear role and responsibility in that process and knew exactly where those roles were demarcated. ALM was central to this, HP's application lifecycle tool, and all the business units, technical test and tool units, functional testers onshore and nearshore all contributed to that central repository of information on requirements, tests, and the metrics of how well these tests were covering application functionality. In terms of asset creation, rather than provide the business units and the functional analysts with a new proprietary interface to pick up and learn, they were presented with an Excel template to define their functional acceptance criteria. So these are the requirements. What are we expecting to see the behavior of our application under test? And those were filled in and imported into the ALM repository as our central point of contact. So this was the first point where we involved the business users in this process, defining the requirements, defining the acceptance criteria that were going to be used to measure the quality of the end goal. The second point where the non-technical contributors were involved was in creating the technical tests themselves, defining the tests to exercise the end UI functionality. And this was in a combination of the Axe automation platform from Odin, providing a non-technical interface to defining automation tests, and also UFT in this particular instance, which was imported into ALM as well, and into the test resources module. So sitting alongside our acceptance criteria and our tests, we now have the automated tests as well defined as part of this process. Another area where non-technical testers got involved was in functional test design, so actually defining the workflows of how these tests played out. And because of the use of this particular platform, there was no coding or very little coding involved other than what was involved from the technical test team. So non-technical testers could define those workflows. And we used code generation technology to generate and implement those automated test scripts in a number of different tools, UFT, Selenium, etc. So slightly different to the kind of scriptless approach that was originally envisaged, but using a low-code approach where you get the best of both worlds. The scriptless type front end, which is familiar to non-technical users, like Excel, those kind of things. But code generation means that you can then tailor and customize and extend your automation in-house, self-service, and change it to meet your specific needs. So slightly different to what was envisaged with scriptless, we're going to this low-code code generation approach to automation in that instance. Test execution, scheduled out of ALM, we're all familiar with that. So let's talk specifically about the Clearstream project. Some of you may be familiar with Clearstream Exact. It's a framework for access to the CSD and ICSD services at Clearstream. Settlement, cash management, all the kind of things that is your guys' bread and butter. There's two aspects to that. The automated access, which is the API level testing, and then the GUI level, which is presented to end users to manage instructions, positions, look at cache and security positions, those kind of things. So it's at the UI level that we're going to focus on for this, the metrics in this case study today. We didn't get involved in the API level testing. So again, this all focuses on securities, T2S, etc. Now I've got some figures as well to look at this. As defined by the business, there were in total, and the slightly changed slide at the top there, but the total number of acceptance criteria defined by the business for this approximated 4,800. Okay, so this was the goal in terms of achieving this, either through a combination of manual and automation-based approaches. And they set themselves a pretty ambitious automation target, actually. 75% of those coverage criteria to be automated, the remaining 25 manually. And what we're saying here is that the project is still running. The guys here are still in flight. And today, we've currently achieved 64% of the automation target, which in total is 45% of coverage of their functional acceptance criteria in a short timescale. So approximately 2,300 functional acceptance criteria covered across 540 test scripts, each of those scripts covering 7 or so acceptance criteria. I've only got 5 minutes left to continue, but this graph, it looks familiar to one we saw earlier about raising our game from 100% on the left-hand side of manual testing up towards automation as being quite a significant goal. And this is the timeline that the project is running to. We're at the midpoint here at month 5 with about 64% or so automated. The completed status there means the fact that the FA, the functional acceptance criteria passed, there's no outstanding defects on them, that sort of thing. So I think you'll agree, quite a significant achievement in terms of UI automation and the percentages over that time because of this structured approach. Build and delivery very shortly. Execution is run across 12 machines across a period of 12 hours. We heard about continuous integration testing and the importance of that in achieving quality. They run a subset, a snapshot of their tests, a critical coverage set every day, and a full regression pack, 144 hours of testing on a weekly basis. So they're achieving the kinds of things that we've heard a lot about today in terms of running testing continuously on an ongoing basis. Very quickly, given the time, the lessons learned from this process. One of them, an interesting one that fell out of this, was the requirement to keep automation defects and application defects separate. Okay, so as automation scaled, obviously as you're building those tests, it's important to track any problems that you face with automated tests. Lumping those in the same pool of defect information as your developers is going to annoy them, because suddenly their defect rates are starting to go up as your testing is increasing. So keeping those two separate, triaging any defects that were found during automation Is it an automation problem? Is it an end user, an environment issue? Is it a problem with the application itself? We've got to triage where those are and assign responsibility. Asset naming conventions, quite an obvious one, but often not thought about. And also, interestingly, this whole case study applies to new functionality. This isn't regression testing. This was automation of new functionality. And obviously that was found more challenging in this particular instance than automating the regression type stuff. Collaboration key to success, obviously getting the business involved in the definition of both the requirements themselves that needed automating, but also tracking those as we went through. And trying to keep away from too much technicality in automation. This low-code approach meant that we could achieve these goals with existing resources without huge amounts of technical input requirements. And obviously, I would say this, I've been involved in this case study, but this collaborative methodology, and I think the guys from Clearstream can back this up, and the tooling that was selected is proving successful over their pre-existing manual testing regime, specifically at Clearstream, and previous automation efforts. So just to thank you, really, and just to say that we have two representatives from Clearstream with us today, Jean-Francois and Hervé, who have a flight to catch after lunch, but I'm sure if you wanted to talk about any of the challenges they faced, their perception of success, and also things like ROI, which we've had questions on, perhaps Clearstream can, the guys from Clearstream can address those for you. But just to thank you for your time, and enjoy your lunch. Thank you very much.